Hello my dear students, how are you? I hope all of you are fine. I welcome all of you to my online class on behalf of Rani J Higher Secondary School. Let me introduce myself. I am Srijesh KR, teaching zoology for you. Today we are going to discuss a new topic called biomolecules. You will be amazing why a class of chemistry in biology. Let me explain my students. Biology has no independent existence without chemistry. Why? Why? Because all living beings are made up of functional units called cells. It is a common fact which is already known by you. These cells possess a special character called life. Being alive is a state of consciousness. It is a state of self-consciousness as well the consciousness regarding surroundings. This consciousness is produced by metabolic reactions that is happening within the cell. So when we analyze these metabolic reactions or the unit in which these reactions takes place, say cell, we will be reaching that these are entirely based on biomolecules. The cell itself is made up of many biomolecules such as proteins, amino acids, fatty acids, lipids, nucleic acids, sugars and polysaccharides, etc. As you have learned in earlier chapters, a metabolically active cell is the defining property of life. So let us now analyze what is metabolism. Metabolism is the sum total of all life activities undertaken in an organized unit called the cell. These metabolic activities are actually chemical degradation or chemical synthesis. We call them respectively as catabolism and anabolism. Say for example, photosynthesis is a metabolic activity which is basically a synthetic process. This is called as an anabolism, and this definitely includes interconversion of compounds. Similarly, respiration is a catabolic activity which again includes interconversion of compounds. So, this metabolism itself is chemical pathways, chemical degradations or chemical synthetic pathways. Now, let us analyze where this metabolism happened. I already told you these metabolic pathways are undertaken in organized units called cell. What is the cell made up of? The cell itself is made up of biomolecules. You have learned the structure of plasma membrane. Plasma membrane contains a bilayer of lipids and integrated proteins within it. So definitely each and every part of the cell is made up of biomolecules. The metabolic activities undertaken by the cell is also chemical processes. So without chemistry, biology has no independent existence. So it is very necessary for a biology student to learn the structure and properties of certain group of compounds by which the cell is made up of. These compounds are called biomolecules. So, biomolecules. To begin with this chapter, we have to first understand how we analyze the chemical composition of a cell, or how we understand what are the components by which the cell is made up of. I have already told you that the cell components are basically biomolecules. Now to begin with, these biomolecules is to be extracted from a given piece of tissue. Suppose you are given a piece of living tissue, say for example a piece of meat or a leaf. There are certain sequential procedures to extract and analyze the biomolecules present in them. To separate and to understand what are the organic compounds present in a given piece of tissue, first you have to grind the given tissue in trichloroacetic acid. Trichloroacetic acid. What is trichloroacetic acid? Its molecular formula is Cl3CCOOH. The COOH indicates that it is a carboxylic acid, that is an organic acid, and it is a good solvent. We have to grind the given tissue in trichloroacetic acid. Now, the trichloroacetic acid is formed by the following reaction: acetic acid CH3COOH on combining with Cl2 chlorine gas, you will be getting trichloroacetic acid and hydrogen chloride gas. The equation is CH3COOH plus 3Cl2 gives Cl3CCOOH plus 3HCl. This is the process of synthesis of trichloroacetic acid. Why we are using trichloroacetic acid? Because it is an excellent solvent. So, grind the given tissue in trichloroacetic acid. After grinding, you will be getting a thick slurry. This slurry now to be strained through a cheesecloth or a cotton cloth. On filtering the slurry, you will be getting two different components. The first component is an acid soluble pool. It is a liquid portion in which many micromolecules are dissolved. So, the first fraction is an acid soluble pool, and another fraction will be there which is called the acid insoluble fraction or retentate. Therefore, this is one of the easiest method to separate the biomolecules and to categorize them into two separate categories, namely biomacromolecules and biomicromolecules. Actually, these macromolecules have greater molecular mass, say for example greater than 1000 Dalton, and these micromolecules have comparatively lesser molecular mass, say lesser than 1000 Dalton. So, macromolecules have a molecular weight greater than 1000 Dalton, and micromolecules have a molecular weight lesser than 1000 Dalton. You know what is 1 Dalton? 1 Dalton is nothing but 1 atomic mass unit or 1 unified mass. Now, here I have listed some examples of biomacromolecules. Examples: proteins, polysaccharides, nucleic acids, etc. And the examples for micromolecules are amino acids, sugars, nucleosides, etc. This method, what we have already seen, is used for isolating or purifying organic compounds actually. But any living tissue contain not only organic compounds but also inorganic elements and compounds. So, we have to employ another method or technique to extract and analyze the inorganic constituents of a cell. It is a bit destructive method. In this method, suppose you are given a living tissue, first you have to record the initial weight of the tissue. Initial weight of the tissue, otherwise called the wet weight. So, you have to record the wet weight of the tissue. Now, you have to dry the tissue. Dry the tissue completely so that all water evaporates. Now, you have to take the final weight or the dry weight of the tissue, you will be definitely noticing a difference between wet weight and dry weight. As you know, the wet weight will be more than that of the dry weight. Now, on subtracting the dry weight from the wet weight, you will be getting the quantity of water that was present in the tissue. So, this step is actually a quantitative analysis. Now, burn the tissue. While burning, all hydrocarbon compounds oxidizes to form carbon dioxide and water, and they escape from the tissue as vapors or gases. Now, what is left with you is ash. On analyzing this ash by a method called ash content analysis, you will be able to list out the elements present in the given tissue. Actually, it is interesting to note that the elemental composition of a given tissue is exactly same as that of the earth crust. In fact, the percentage composition of elements is far higher in a given tissue, is far higher in a living tissue than earth crust. For example, the percentage composition of carbon in the earth crust is 0.03%, whereas in a living tissue it is greater than 18%. Though the amount is different, the composition remains the same. Now let us study which are the various biomicromolecules. One of the most simplest biomicromolecules are amino acids. So now we are going to explain the chemistry and the structure of amino acids. What are amino acids? Actually, amino acids are substituent methane. You have learned in smaller class what is methane. Methane, its chemical formula is CH4. Its structure is carbon, single bond hydrogen, again the same. So 4 hydrogen atoms are occupying at the valency of carbon, CH4. So this is methane. Amino acids are substituent methane, meaning that the hydrogen atoms of this methane is substituted by something else. Here let us see what is substituting the hydrogen atoms in a methane to form amino acids. Amino acids are formed when this methane or the hydrogen atoms in the methane is substituted by first an NH2 group, which is called amino group, then an acidic group COOH, carboxylic group or carboxylic acids. Now one position is similar to the methane, it is hydrogen, and the fourth valency or the fourth electron can be shared by any group or element. So the general structure of an amino acid is amino acid contain a hydrocarbon, meaning that a central carbon and a hydrogen attached to it, an amino group, an acidic group, and a functional group here, which can be any element or compound or reactive group. It is usually denoted by R, which is called the functional group of amino acids. Why is it called the functional group? Because based on the character of this group, say now it is called as R, based on the character of this R, the entire functions, entire nature of the amino acids will be changing. So this R is considered as the functional group of an amino acid. So now we can define the amino acid as a hydrocarbon because it contains a carbon and a hydrogen. A hydrocarbon that has an amino group NH2 and a carboxylic acid group COOH. In addition to that, it also contains a functional group R represented by R. So this is what the general structure of an amino acid. Keeping in mind this general structure, you can study the various types of amino acids. Actually, there are around 500 amino acids in the nature. But out of these amino acids, 20 amino acids are used in the human body for the synthesis of proteins. Hence, 20 amino acids are called proteinogenic amino acids. Proteinogenic in the sense they are used for making proteins in the body. Out of these 20 amino acids, 9 amino acids are essential amino acids that cannot be synthesized by your body, and hence such amino acids should be supplied through the diet. The remaining are called non-essential amino acids. Now, as an example, we have the structure of 3 amino acids to study. Let us see these 3 amino acids. The first one is glycine. The first amino acid to study is glycine. So let us see what is the structure of glycine. The structure of glycine will be, again it is an amino acid, so it contains hydrocarbon, an amino group NH2, an acidic group COOH, and if it is glycine, its functional group is hydrogen. So if in an amino acid the functional group is occupied by a hydrogen atom, then it is called glycine. This is one of the most simplest amino acid which has a structure NH2, CH, COOH and hydrogen. This is glycine. Another amino acid is alanine. So let us see what is the structure of alanine. Again, alanine, since it is an amino acid, it contains a hydrocarbon, an amino group NH2, a carboxylic group COOH, and its functional group is methyl group. Do you know what is methyl? Methyl is the simplest alkyl. What do you mean by an alkyl? An alkyl is produced when one hydrogen atom is removed from alkane. Say for example, methane is the simplest alkane. Its molecular formula is CH4. When one hydrogen is removed from this methane, it will be CH3, which is an alkyl formed from methane, and this is called methyl. Since it is not satisfying, these hydrogens are not enough to satisfy the valency of carbon, it will be a reactive functional group. So when the CH3 methyl group is occupying at the 4th position, then the amino acid will be alanine. So the structure of alanine will be CH, NH2, COOH, and the functional group is methyl CH3. Similarly, another amino acid whose functional group is hydroxymethyl. This amino acid is called serine. So let us see what is the structure of serine. CH, hydrocarbon, amino group NH2, acidic group COOH, and I have already told you its functional group is hydroxymethyl. What is hydroxymethyl? It is CH2OH. So when the functional group is hydroxymethyl, this amino acid is called serine. So we have learned the general structure of amino acids, which is NH2, CH, COOH and a functional group which is represented by R. This functional group can be any element or a reactive compound based on which the entire chemical nature of the amino acid depends, and hence it is called the functional group. Now, as an example, you have 3 amino acids to learn. The first one is glycine. The structure of glycine is again similar to your common structure, but the functional group is hydrogen. So the structure will be NH2, CH, COOH and hydrogen. This is glycine. Now the second one is an amino acid whose functional group is methyl, CH3. Now its structure is again amino group NH2, hydrocarbon CH, COOH carboxylic acid and a functional group methyl, CH3. This is an amino acid called alanine. And the third one is again another amino acid that has a similar structure, but the functional group is hydroxymethyl CH2OH. So its structure will be NH2, CH, COOH and CH2OH as the functional group. This amino acid is called serine. So in our syllabus, we have only 4 structures regarding amino acids. First one is the general structure and 3 examples.